Hello, I am Ali Tariq from 10x Engineers. I work as Associate Hardware Engineer on RISC-V architecture. In this video, I will be showing you how you can compile an application from source for RISC-V architecture. The procedure will be same for Linux-based environment even if the architecture is different. So first of all, the application for this will be Python, and the prerequisites before doing this is that uh, you should have RISC-V GNU toolchain installed, and you must have an environment on which you can execute RISC-V compiled binaries, which can be QEMU or which can be RISC-V hardware board. So first of all, the application for this video is going to be Python. So I am going to python.org, and over here I am going to go to downloads, and you can see that there is a source code link over here. I am going to click on it, and the application or the source code of the application which I am going to use can be any one of these. For today's video I am going to use 3.8.17, just randomly selecting it, and I am going to use gzip source starball. So you can see that it has started to download. So now it is downloaded. Let me navigate to the directory and extract it. So here we can see the contents of the extracted Python file, and before going forward I would like to tell you that in the source code of the applications usually there is a configure script for the applications which are based on C language, and also even if they are not based on C language, most of the developers include this configure file for Linux based environments if they are able to compile on Linux based environments. In other cases there can or cannot be this configure file. So what this configure file does is that it produces a make file, and based on the arguments we give to this configure file, the make file can do a couple of things and install our softwares. So I am going to execute this configure file, and I'm going to give it the prefix, and in the prefix we give it the path of the directory where we want our application to be installed or compiled. Otherwise it will install it to the root folder. So before giving it the path, let me create a folder. So the folder is created. Let me navigate to it, Python Cloud 5, and if I get the path and put it over here, so it's given. And other than that, as we are cross compiling on x86 architecture for RISC-V architecture, we have to give host and build. The host will be the architecture on which the binaries compiled will be running, and this will be RISC-V 64 Linux GNU for our case. This depends on the toolchain you have installed on your system. I have RISC-V 64 Linux toolchain installed, and there is another parameter called build which we should pass and give it the architecture on which we are actually compiling this source code. So this is x86 64 and Linux GNU. So we are pretty much done. Generically this is what cross compiles a software based on host and build. So let me press enter. Okay, it is saying configure read elf for the host is required for cross builds. Okay, I actually passed some incomplete argument, so this should do it. Okay, it is actually doing it. So here you can see that RISC-V architecture is pretty new, and there are a couple of things which may or may not be present in the RISC-V architecture. So you may want to disable some features, for example IPv6. I am going to paste it over here. Oops, that was the wrong one. Okay. So now it is telling us that there is another feature which we should set, and I will preferably set it to no. And there is another thing which we need to set. This will hopefully be the last thing that we need to set so far, and I will also set this to no. Okay, so now we have makefile in our present directory. You can do ls and check it. Here you can see that makefile is produced. Now all you need to do is execute make, and with make you can also give the number of threads it should make while running the make command. I am giving it the nproc, which means the total number of cores present in my machine. So I am going to run it. Here you can see there is a performance counter and the CPU is being used 100%. So it is using all the computing power of the machine. So finally it's done, and some of the modules have not installed. You can see here failed to build these modules, and there might have been some other modules which are not installed because the other necessary bits were not found in the environment. So by this point you will be able to see the Python binary over here. Now to install this binary to the path you have given in prefix, you have to run make install. Here you can see it is installed. Now we will be able to see it in our directory. Here you can see bin, include, lib, share are actually present. If we go to the bin folder and check it, we will be able to see that Python 3.8 is here. Now if we actually try to execute this Python file, okay, what we actually want to do is that we want to execute it, but it is unable to find this specific linker file over here. So we have to be running some RISC-V or hardware architecture or some RISC-V emulation platform. For this video I have set up QEMU as a RISC-V emulation platform. So if I use QEMU RISC-V you can see that it is completely running without any errors. We have passed a RISC-V sysroute for QEMU RISC-V to find some necessary bits to run this, and here we can do anything with it as we want. Let's say printing hello. So it is printing hello. So Python is completely running on the RISC-V emulation based architecture. So this was all about compiling the application from source for RISC-V architecture. Now a little bit more about all of the hassle for preventing you to do all of this. For setting up everything, you can go to cloud5.co, and here you can see the platform which we are providing for running applications on RISC-V architecture. And to spice things up, we are actually providing the first few of our software developers the free access to Cloud5 for some of the time, and you will be able to access it completely free. And also I would like to tell you that we have all the documentation available over here. Here you can see that user guide and presentation slides are available, and other than that we have hardware boards as well as emulation instances. So if you want to use hardware boards and do some of the interesting stuff on that, you will be able to do that. So all you need to do is scroll up here and press on get access, and this will take you to fill the form and get the access. And after that you will be able to go to Cloud5 dashboard, and if you have your source code available on GitHub, you will be able to integrate it with this CI environment. Now even if you need to use the board for direct access, say SSH, we will be able to provide you that, but for that you will have to contact us on our email. So I hope that you found this video very interesting. I hope you have a good day. Goodbye.